Hi everybody, can everybody still hear me? Okay. So welcome. So as Sarah said, today we're going to be talking about microplastics, tiny pieces, big impacts. My name is Nikki Sullivan. I'm the education coordinator at the Blue Ocean Society for Marine Conservation. And so I'm going to kind of go over what are microplastics today, as well as what is our research program studying them at Blue Ocean. And then at the end, I'll leave some space for questions that you may have occurred throughout the program. So that being said, our mission at Blue Ocean Society for Marine Conservation is to protect marine life in the Gulf of Maine through research, education, and inspiring action. So we have three different kind of sections that we split Blue Ocean up into. So the kind of core of everything we do is actually whale research. So our organization is a nonprofit that was started by two friends that met on a whale watch internship, and this that was focusing on the area of Jeffrey's Ledge. So if you were here for my last presentation, I talked about it a little bit more, but if you weren't, Jeffrey's Ledge is an underwater mountain range, and along this range is a major feeding grounds for many different animals, but including whales. And at the time, back in the 90s, nobody was studying this area. So this is kind of the core of how Blue Ocean was started. They started collecting data just as interns, and they were trying to share it around, and nobody was taking the data. And if they were putting it in the back of a drawer and was kind of just getting shoved there, and nobody was doing anything with it. And they said, you know what? We're going to keep our research and we're going to do something with it. And this has just evolved over the last 25 years from a small whale research organization to a nonprofit that works to protect a large portion of the New Hampshire seacoast, as well as parts of the southern Maine seacoast, and as well as the northern Mass seacoast. So in the effort to learn more about whales, but not only that, get people involved, but as well as work to better protect them, our marine debris research program was born. So this came a few years later in 2001. And it started with just beach cleanups. People were so excited about through our education on the Whale Watch program to really try to help these animals. They wanted more. So it started with just a few small beach cleanups. And we were like, you know, if we're gonna be out there, we're a research group. We're gonna take and quantify what is actually on the beach. Not just that there's trash on the beach, but what kind of trash. So we can better understand where it might be coming from. We can educate people in our community about what is the actual trash that's out there, but also hope to prevent it there in the first place. And this has just evolved again very naturally into our education and outreach sections. So we have a 65-foot inflatable whale that is pictured up there that students can go inside and learn about whales inside and out. And it is turned into through a very, very awesome volunteer of ours. We have a fishing line recycling program where we are taking fishing line that has been used from fishermen. We have multiple bins at multiple harbors and popular fishing spots. And our team of volunteers gets it back to Harvard and is actually able to reuse that fishing line to make other plastic things. It has evolved into our Blue Ocean Discovery Center on Hampton Beach, which is a low-cost education center with touch tanks, some other really cool exhibits, and again, focusing on marine debris and whale research, as well as a bunch of other programs. I could probably spend an hour if you're going through all the different things that we work on, but that's just some of the highlights. So in better understanding marine debris and the long-term effects, especially on whales, microplastics research started in the 2020s for us. So, what does a sample of our data look like? So we are, on our beach cleanups, we are picking up a number of items and we're logging this on our data sheet. So anyone can join our beach cleanups. We do beach cleanups with about 4,000 volunteers every single year. We clean any beach in southern Maine. Farthest north we'll go is about Portland, all of New Hampshire, and then northern Mass. I would say we've gone down as far as Ipswich, but usually it's around Newburyport. It's kind of, or in Salisbury, is a little bit more close to where we're actually cleaning regularly. And so by condensing all of this data, what we found over the years is that the top items that kept repeating in all of our data sets are cigarette butts, unknown plastic pieces larger than 10 centimeters, plastic pieces 5 millimeters or less, plastic pieces of 5 millimeters to 2.5 centimeters, and then other. So other, you cannot predict everything that we find on a beach cleanup. The stuff that we find never ceases to amaze me. And so we only have a list of 47 things. But most of that other category is other variations of plastic. The weirdest thing I have ever found is a burnt mannequin foot. We found a whole wrapped ham, completely saran wrapped. And there's been a large, long list of random toys, toothbrushes, all sorts of crazy things. And that kind of makes up our other category. But the repeat things that we are seeing are these small plastics, cigarette butt filters, which are full of microfiber plastic. And then also not pictured here, coming up in some of our other data sets, is different things such as film or wrappers. So again, another single-use plastic. So this is actually a really great snapshot of the type of debris that we most find on the beach. So it's so easy to go out onto a beach and be like, you know what, this looks clean. But as we start actually picking things up, it always blows my mind how something can look so clean from just staring out of it until you really start getting down and examining it. And it usually, it is for me, many cleanups I've showed on and I'm like, oh, I hope we find enough trash today. Otherwise people are gonna think I'm nuts. And then we always do find enough trash because it really is out there. It just is much smaller than we anticipate. I think a lot of the earlier beach cleanups, and this is reflected in our data, and where beach cleanups really started to get popular in the early 2000s, we were dealing with really big nappa debris. But that debris has changed over time. And now we're seeing things in a much smaller lens, but it still has a really big impact. So microplastics are tiny plastic particles, less than 5 millimeters in size. So up here, we have an example of a pure plastic. So this is a primary microplastic. So this example is a nurdle. So nurdles are basically little plastic beads, and they get melted down to make any sort of plastic object. There's many different types of nurdles that are made up of different things, but this is the primary source of plastic. So this is melted down to become that lawn chair, or the Tupperware container, or melted down to become the plastic bottle. The second type of microplastic is, the second category is secondary type microplastics. So these are split up into 4 main categories of foam, film, fragments, and filaments. So foam, picture the little pieces that make up a styrofoam cooler. And you know, if you were to tear at the sides or to pull open the top, those little, or if you peel the tape on any sort of styrofoam box, all those little white circles come off. That would be an example of a microplastic foam piece. It could also be, if you've ever had a toy football and like your dog or child pulls apart at it and those little chunks of foam start coming out of it, that's another example of foam. Film, I tell everybody to picture the juice box straw. So like the Capri Sun or the Juicy Juice box comes in that clear plastic. The straw comes in that clear plastic. So pieces of that clear plastic would be categorized as film. So there's some other different types of candy wrappers, especially like hard candies that you would suck on, like those butterscotch ones. That would be another example of film. Fragments are harder plastics, so this would be larger items like a kid's sand toy breaking up into pieces would result in a plastic fragment, and just anything made of that same type of hard plastic material would get described as a fragment. So filament, on the other hand, refers to more strings, but picture more fishing line type or something that's a little bit thicker. Yeah.
The nodules that you showed first, those are used to make plastic, so how do they get in the ocean?
So they can end up in the ocean through spillages. So these have to be transported around from place to place. They get spilled. We don't always know how everything gets anywhere, but it could simply be like somebody has a bag, because you can also use these at home for different home plastic projects or resin making and different things like that as well. So it could simply be somebody bringing a bag in, the bag gets ripped open, it gets spilled in the parking lot, and they roll around. Otherwise, I also have a lot of questions as why we are finding those, but we actually found over a few hundred of these ourselves in Great Bay, like in a residential area. No idea why it's there, but something we find. So why is it in the ocean is a very good question. So going back to our secondary types, so the filaments again are that more string-like material, but again, it's going to have some sort of plastic base. Another example of filaments could be as cigarette butt filters break down into singular strands. That could also become considered a filament as well. Depends on what level of breaking apart or what stage it is in. So where do microplastics come from? How are we getting all of these things in our environment? Why are we finding them? So up here I have a number of different examples, and this is just gonna kind of show you how different items become different sources of microplastics. Sorry, I'm like dehydrated today, I'm so sorry. So I'm gonna start at the bottom, since this is such a random thing. Kind of goes again, it touches back on that other category that I talked about. So this is actually a beanbag chair, starting there on the bottom left. And this is actually located out on the Isles of Shoals. So this is a full beanbag chair, full of those little styrofoam foam balls that I talked about. And so if this had burst while it's out on the island, this would have resulted in hundreds of pieces of foam ending up in the environment. So if I've definitely seen a beanbag chair be ripped, it's definitely a common occurrence. So beanbag chairs are one thing as well that might be packed something like a nurdle, or kind of that pure plastic as well. So if these burst open, these would definitely enter the environment in a very, very large amount. Moving on to the next one is actually a very, very common item, and we have been using this item very commonly actually in our marine debris art program because we have such a collection of them. It is called a lobster tag. So that lobster tag is that yellow piece of plastic that is in between that person's fingers. So you can see it's green, has this little green circle, and there's all these bunch of numbers on it. So every single fishing trap, particularly lobster or crab, that goes out into the water, all the way, you can be used all the way into Canada, so this isn't just a USA tool, but it is used by the fishing game departments to better understand where fishermen are allowed to fish, what harbor they come from, and what state and what area sometimes they are allowed to fish in based off of the harbor. So every single trap is employed with one of these, and we find hundreds of them on the beach. We actually collect them all to better track how plastic moves through the ocean in partnership with Center for Coastal Studies. So we enter in all the data, and we've actually been making mosaics out of these, which are pretty cool. But these fall off the traps, and then over time they break into smaller and smaller pieces and become that hard fragment plastic that I mentioned earlier. The next thing is a lobster trap. So on our new age lobster traps, they are metal coated in this plastic rubber. Plastic rubber does save the fisherman's hands for sure, and helps to stop the metal itself rusting. But as the water wears down on the trap, it wears down this plastic too. And so all this plastic comes off in chunks. And this is something else that's really common for us to find in the sand on our beach cleanups, and especially if there's a trap around that's a little bit older or a piece of ghost gear. The next one is actually a balloon found somewhere in the Gulf of Maine by our whale watch boat. So balloons make up 20% of the items we find out on the water. They're very small impact on land, making up only like 0.2% of our data found on land, but it makes up 23% of our data found on the water. So while this isn't something that is necessarily right on shore, as these balloons break up, they eventually pop and deflate. They become smaller and smaller pieces, especially of film. And if you think about a Mylar balloon, those metallic pieces flake off, and then you're left with this kind of clear shell. So that comes out into a film. Then we just have trash here simply on the ground. So there is the source of microplastics that come from people just simply throwing trash on the ground, it breaking up. So this is a little bit like the most intentional kind of source of microplastics. Up here at the top right, we have two different trash cans. So we have one that's more residential, and then we have one out in a park. So these are both over full. And so if there's no weather events, this trash will stay in there, hopefully, until it gets to the garbage truck. Because as long as it makes it into the garbage truck, it really, it won't become a microplastic most likely until it reaches the dump. And so it starts going through that process. But weather events definitely have a really, really big impact on trash cans. So what will happen with both of these cases, if the wind blows or there's any sort of substantial rain, the trash is going to get blown out of the trash cans. It's going to end up on the ground. And there's this phrase that all rivers lead to the ocean, and it's kind of like that philosophical thing, but it's actually real as well. All rivers lead to the ocean, and they all connect back to the ocean. So what's happening is these items are getting caught in the wind, they're hitting a water source, whether it be farther upstream in a river or directly into the ocean itself, and they're getting washed out, though, eventually into the ocean. The fact of hitting large bodies of water breaks up items, particularly plastics, into chunks, and they're hitting things like rocks and trees and branches, and sometimes water is really high powered. So this is all breaking up those pieces of trash. So it doesn't mean that it doesn't affect upstream too, and it doesn't affect those wildlife and individuals, and it doesn't mean that it doesn't affect a whole plethora of ecosystems. Being an ocean partly based organization, a lot of our current research is in oceans, but we are expanding more up the rivers as well. Because this has a very, very long track, basically, to go that you can have microplastics and trash present. Cigarette butts is another really common one. I feel like I've gone over this one, so I'm not going to beat that one to death. The next one here is simply a plastic fork. So you can see this plastic fork, there are tines on the top. You can already see those breaking up into smaller and smaller pieces. This would become fragments. And then here on the end is a piece of fleece. If you did not know, fleece is primarily plastic fibers. So as the fleece material sheds those fibers, you're actually putting filament right into the environment. So in your washing machine, the washing machine spins the clothing round and round, and actually these filaments shed out through the water. And so they come intact with our water system through that way. It may be a long journey, but basically they pass through a lot of the filters that catches bigger items because they are so small. Yeah.
If we find one of those lobster trap tags, should we turn that in to somebody?
You could definitely mail them to us. You just have to include the date that you found the tag, as well as the location, for us to be properly, and you can absolutely mail those to us. So effects on wildlife. So this is not my photo, but I was so moved by this photo I have included it. So this is taken by the North Carolina Aquarium on Roanoke Island, and they work with a nonprofit group called Nest. So this was taken back in June of 2025, so this is very, very recent. They posted this to their Facebook page this summer. And so this is a sea turtle x-ray up on the screen. So this sea turtle was found on the beach looking very sickly. They really weren't sure why, so it was brought to the animal hospital. And on the tray are all the pieces of plastic this turtle passed through its digestive tract while in the care of the North Carolina Aquarium. So as you can see on this tray, there is hundreds of pieces of plastic. So this jumps right into how do microplastics affect wildlife. So this sea turtle most likely ate plastic objects thinking they were food. So especially for sea turtles, this is a really common occurrence. One of their favorite foods are plastic bags, and they look just like jellyfish in the water. The amount of times we've seen a sea turtle and you see it eating a jellyfish, you're very worried that it's actually a plastic bag. If I put it up here, you'd have a really hard time telling it as well. So they believe that this animal ate all of this, thinking that it was eating its normal foods. And what happens is when you have this much plastic in your system, you're not absorbing the proper nutrients you need. So this plastic is taking up space in its digestive tract, and it obviously ate this a while ago, and it's taking a long time to process out of the body. Meanwhile, it's also in the body. Plastics contain a lot of different chemicals. And so the body is trying to break down these plastics, so these chemicals are going to be leaching into the body as well. So they believe that this is really what was making this animal sick, is the high amounts of plastic in its system and it needing access to high amounts of proper nutrients very, very quickly to be able to pass this. So it's just, again, it's absolutely astounding to look at how much plastic was in this animal. And you can see by the x-ray what it looks like in its digestive tract. All those little dots are all different pieces of plastic where it was all sitting in its digestive tract. So another example of effects on wildlife is our humpback whale here, but it really goes for all whales. So whales are a filter feeding animal. Primarily our largest whales do not have true teeth. So there are two different categories of whales or cetaceans. So there's the dolphin category, where you have animals that have true teeth, things like orcas, sperm whales. They all have bone teeth just like you and I, but our largest animals on the planet, and our largest animals such as the blue whale, the finback whale, minke whale, humpback whale, they are all filter feeders. So as they are feeding, they take big gulps of water like pictured here. And so their entire throat expands all the way down. They can fit about 2 bathtubs worth of water in their mouth at one time. And they have these filtration plates that line just the roof of their mouth. They're made of keratin. So if you feel your fingernail, that's what a baleen plate feels like. Because keratin is the same thing that your hair and fingernails is made out of. So they have 400 to 500 of these that line just the roof of their mouth. So they take big gulps of water and they push that water through those sifting plates. And what happens is small creatures such as krill, plankton, zooplankton, copepods, and small fish all get stuck in that baleen. They spit the water back out their mouths, as you can see this whale doing here, all that water draining back out into the ocean. And then they take their tongue and they lick it clean. And anything that gets caught in that apparatus is going into the stomach. Their throats are only about the size of a dinner plate. So laying mammals, just like you and I, they actually can't drink salt water, getting all of the water content they need from their food. So these animals are highly affected by microplastics. They're not using their hands or catching food individually. So they're indiscriminately scooping everything that's out in the ocean. So they're not saying, oh, there's a copepod over here, but there's a fragment of a bottle cap over there, so I'm not going to take a gulp here. It's just, they're not built and they're not designed to have to deal with this type of pollution in their environment. So these animals, particularly humpback whales in the summertime, eat 2,000 pounds of food a day in order to maintain their body weight. So if you wanted to eat like a whale calorie-wise, you would have to eat over 2,000 cheeseburgers every single day in order to eat like a whale. So they have the potential to take in a lot of toxins. And so what happens with these whales, similarly to what we saw with the sea turtle, is if they are not able to pass them, these plastics and things sit in their stomachs. And so being a migratory animal, they need to get a lot of nutrients every single summer. So when humpback whales are in our area, it's the golden corral season. All they're doing is eating and sleeping, and they're getting ready to migrate back down to the Caribbean where it's much, much warmer. So if they come in contact with high amounts of plastic, instead of taking in plenty of food, they're not going to be eating enough to survive their migration potentially. And most importantly, when you're talking about a population, they're not going to be able to reduce necessarily. If the mothers aren't getting enough nutrients, then their bodies aren't going to be prepared to raise and grow an entire 500-pound baby. So down in the Caribbean, the foods that they eat up here, all those planktons, aren't present. So if you were to compare two different jars of ocean water, one from the Gulf of Maine and one from the Caribbean's is going to be crystal clear. And that is because they don't have the plankton and things that we have in our water. And that's why we can't see to the bottom. Because our water is so nutrient dense, while the Bahamas or Turks and Caicos water doesn't have that type of nutrients. So when they're not here, they're not eating. So it's really important that our environment is clean for these animals. Whales are really important as an indicator for ocean health. And that is because they're a living nutrient pump, which is a fancy scientific way to say that these animals are built to eat a lot, so they poop a lot and fertilize the ocean. So they are taking high amounts of nutrients and recycling it back into the environment. And that is part of the reason that the Gulf of Maine itself has such a variety of plant life. Otherwise, there'd be nothing cycling this nutrients that is in this water. There'd be nothing cycling that plankton out to the level that whales can. So what I'm touching on through all of this is a process called bioaccumulation and biomagnification. So bioaccumulation is the gradual accumulation of substances in organs, tissues over time. So this occurs if that we're talking about right now something that a system that occurs in one individual. So this would be just in the sea turtle, just in the whale. And so what happens is, as pictured in here, is the animal itself eats something that is contaminated with, in our example, is plastics, and it absorbs the contaminants faster than it can excrete or metabolize them. So that was the example we saw in the sea turtle in particular, is that it was eating more plastics than it could metabolize out and excrete out of its body. So then there leads to something called biomagnification, which is pictured here in this diagram. Oh, sorry. So this is the increasing concentration of persistent toxins as they pass up the food chain. So this occurs across all the trophic levels. So what's happening here is that the smallest pieces of life, so our plankton, our krill, our microorganisms, aka ocean bugs, for lack of a better term, are eating the trash. They're eating the plastic. So you can see this also pictured by this image is from the American Chemical Society from a study they did in 2013 over on the right. And so these are bivalve larvae, so clam larvae, as well as a crab larva and a copepod, all with plastics inside their system. So those green highlighted pieces are actually individual pieces of microplastics found in the system. So as you can see, there's only 1 to 2 pieces. But what happens is there's a larger animal behind it that eats multiple of that animal. So obviously you're not going to eat 1 copepod and survive your entire life. You're going to eat hundreds of copepods. So let's just say that fish, the first fish, only ate 50 pieces of, or 50 copepods in its lifetime. Very, very sad starving life, but it only ate 50. Now that fish is eaten by this bigger tuna. But again, they're not gonna just eat 1 fish for their entire life. So let's say that that fish eats that fish's, I don't know, it only eats 25. So you can see that now that fish has 25 fish inside its body, each with 50 pieces of plastic inside of it. So now that fish has taken on 100 pieces of plastic, and it really didn't even eat enough to survive its whole lifetime. Then the highest level of the trophic level comes, and it consumes that tuna fish. So it could be an orca, but in this case, we're going to use a human, which is us. And so the highest levels of the trophic level, which are including us, are getting the most toxins because we are eating the most concentrated things with plastic in them. So this is not the only thing that we are finding plastics in. It's not seafood, so we are finding them in things such as salt, which kind of sounds straightforward if you're talking about sea salt, but not just sea salt, as well as things like honey, which is such an interesting one because how would you think the animal that is converting pollen into a food source has anything to do with plastic? But it's being found in the honey as well. Microplastics can actually enter our body as well. Not just through ingestion, but also through inhalation. So these plastics are actually small enough to move through our bloodstream. And by the age of 50, there are studies that indicate there's up to 7 grams of plastic in our brain. So that is the same size as a small spoon or a credit card. Those are all 7 grams of plastic. But we really don't know what the consequences are, the full scope of the consequences. We know that these materials have carcinogenic chemicals in them. We know based off of looking at animals like whales that there are endocrine disruptions that are happening in their system that are being linked to plastics. There are a number of different studies going on about what it could be doing to our brains. So the biggest one that came out that has the kind of the least controversies against it, or the least kind of negative feedback, has definitely been the one where they have discovered that 80% of all placentas tested from, or fetuses tested from pregnant women had microplastics present, and 100% of female placentas that have been tested already have microplastics in them. So that means even before life is coming out to the planet, they're already being exposed to microplastics. There are some other studies. There's a lot of difference of opinions when it comes around it. There are studies that are actually looking to link things such as dementia and other brain disruptions to microplastics possibly as well. There were some more things against that study, but there is also a lot of evidence that would which is why the different health societies are looking into it. So plastics have components such as BPA, biolatidates, and heavy metals, and these all disrupt our nervous and reproductive systems. Those are known facts. Just how they are disrupting them is yet to be determined. So, for all of these reasons, and many, many more, we have began to research these, research microplastics. So our research focuses on confirming the presence of microplastics in New Hampshire. So are they present here? Can we find them at all beaches? Because until we got out there, there was no way of knowing. We could say there's microplastics out there, but until you actually put them in a bag and actually look at them, it's all kind of up in the air. So, are there microplastics here? But then also identifying what are the types of microplastics that we have here in New Hampshire. So if you looked up the world data, plastic fragments is actually the number one. But if you look at just New Hampshire data, 58% of our microplastic data shows foam. And so if we went just attacking those plastic items, we wouldn't be educating, we wouldn't be targeting the right things, because we now know that for New Hampshire and for our area, we need to study more of the foam types of sources. So we're also working with stakeholders to find collaborative solutions. This program is partially funded by Sea Grant, and we also work with the Shaw Institute up in Blue Hill, Maine, and they have a forensic machine where they're actually able to analyze our plastic samples, and we are able to tell us where they might originate from. So what is the source? So what kind of plastic it is, what kind of foam it is, and that might lead us to let better know where those microplastics are coming from. So we study beaches April through October. We have focused on 5 beaches in New Hampshire. This is Wallace Sand Beach, Genesee Beach, which are both in Rye, New Hampshire, Hampton Beach, Hampton Harbor, and Seabrook Beach, which are all in Hampton and Seabrook. So these beaches have been sampled 1 time per month, April through October, for the last few years, starting in 2021. There are 5 sandy sites sampled at each beach. The samples are always taken at the highest rack lines. The highest rack line is where the highest point of the tide last came to. So you can always tell because there's either some side of like plant debris or there's kind of this like watermark that comes up in the sand. So that lets you know where the highest water line has happened recently. And all of our samples are actually taken by volunteers. So different volunteers sign up and they commit to collecting these samples, and that's how we do our sampling. Then we also have a group of volunteers that helps us sort them. So we take everything in a bag, whether it be organic or non-organic, and then we have volunteers go through and identify what are actually microplastics and what are things like pieces of rock or different things like that. So this is what one of our sampling sites looks like. So this is Genesee Beach, I believe. And so here are the 5 sites. So there's North Quadrant 1, then there's Center. So every single site has the same setup where they have one at the most north point, one at the most south point, and then 3 in the center. So this is kind of what our kit looks like. So in the center there is our sampling quadrant. So we take string with little stakes and make a square. And we line this up of how we pick our spots. So we don't use a GPS, but we use a very specific point on the beach that we line up with. Like there's a few different of these beaches, there's specific pavilions that we can line up with. And so we know that we line up with this pole of this pavilion at north. And then we write down the GPS coordinate of what we took. Because the rack line is changing all the time, it's really hard to use a specific GPS point. So then we have 2 buckets and 2 sieves. So we have a larger sieve that takes out larger objects, such as larger rocks or things that aren't microplastics. And that is our large sample. We still bag those to account for any sort of trash that might be in the quadrant that's not a microplastic. And then we have a small sieve where it allows the sand to fall through and just leave behind debris. Everything is put into 2 different bags, and those are later sorted. So, as I said earlier, the most prevalent microplastic in New Hampshire is foam, making up for 58% of the total microplastics sampled from 2015 to 2024. So the root causes, how are we getting this? All of this different plastics into our waterways. So there's this overuse of plastic products. Our economy and our industry, all different industries, are highly full of different types of plastics. We utilize plastic for a number of different items. There's a lack of producer responsibility. And so that also results in a lack of consumer choice. So that really goes into packaging. We can't, if you go to the grocery store and our only options are getting things packaged in plastic, it kind of limits our ability to not use plastic. We also have a big single-use and disposable culture, trying to make everything easier sometimes isn't always the best. So we use a lot of items that we use once and throw it out, but the material is something that lasts for generations. We don't have great waste management systems. We're putting these things in landfills and they're not exactly very contained. So those weather events, especially caused by climate change right now too, as we're going through and seeing more weather events, it increases the likelihood of these events happening. When we're having more floodwaters, when we're having more crazy weather patterns, so we're seeing more storms, more hurricanes, stronger winds. This is again all resulting in debris moving around and is causing it to break apart. There's also just lack of awareness and regulation. We've gotten a lot more attention on this issue recently because of the different health-related studies, but there is definitely still a lot more room for improvement. So if you have been really moved by this presentation and are like, I would want to start sampling for microplastics here in Maine, please let us know, because we have a wonderful sampling and sorting toolkit, so you can start helping us study microplastics in the southern Maine area. If you'd like more information, let me know and talk to me afterwards. I'm happy to give you my card. You can either take a picture of this QR code or we can send it to you. My parting message as well of what can you do to help fight microplastics. So the biggest one, refuse it whenever you can, particularly single-use items. It doesn't matter if you are perfect all the time. No one's perfect all the time in refusing plastic because it's just not possible. But we firmly believe at Blue Ocean that if we all are doing our best and we all can try to make at least one good choice, it does still make a difference and it does still impact it. So refuse it when you can. Reduce it, so if it's not something you can entirely get rid of, can you use less of it? Or is there another option? Is there a biodegradable option? Is there an option that isn't plastic? Reuse it, so another great thing is there's a lot of different reusable products coming out now. Water bottles is one of the best ones. We find so many bottle caps on the beaches as well as another, and they're very close to that microplastic range. So just by taking a reusable water bottle, so if you thought about if you used a single water bottle, used water bottle every single day, you'd use 365 water bottles. So just by getting one reusable, you could save over 300 single-use items. Another one that's really great is Ziploc. Instead of using Ziploc bags, reusable containers, they come in glass and metal now, which are really great alternatives because those are more recyclable than plastics. And then there's also reorient and diversify. If you are a business owner that does have the power to try to make different choices and provide people different products, or if you own a restaurant or different things like that, are there items that you have that you could offer that are biodegradable or are another option and an alternative to plastic? Sorry. So just some upcoming events with Blue Ocean. I will be back here in June, but if you'd like to see this sooner than then, we have a symposium coming up at the Star Theater in Kittery, or you can join us via Zoom on March 27th. Our next beach cleanup is April 4th at Hampton Beach. I also wanted to take this time to also say special thanks to the York River Watershed Stewardship Committee for allowing me to be able to be here tonight and with a number of other different programs. So thank you to them, and definitely if you are interested in being more involved in the Rivershed area, please make sure to grab their information before you leave here today. Also some final resources. So if you'd like to learn more about our microplastic data and the actual numbers, you can scan this QR code that will explore our microplastics research. There's also another QR code that I'm going to leave up here that has all of our REACH cleanup info. We're planning to do more cleanups, thanks to the York River Watershed Committee, to do more cleanups here around York. So this is where you can learn more about it, but also visit our calendar and you can view all of our different cleanups and be on the lookout for the ones coming up in York. And to learn more about anything that we do or get involved in anything, volunteering, and all of the above, please visit our website. That being said,